The first problem is, if we have a matrix A is equal to 1, 3, 5, 7, show that the matrix A is invertible. Now, the matrix A is invertible means the inverse exists, and also find A inverse. So, the solution, we have to find out the determinant of matrix A, that means 1, 3, 5, 7. Then it is 1 cross 7 minus 5 cross 3, and the result is minus 8, that is not equal to 0. So the determinant of A is not equal to 0. So the matrix A is invertible. Now we can find out the adjoint of A. So the adjoint of A is equal to, that is 7 minus 5 minus 3, 1, the cofactors and its transpose. So the adjoint is now 7 minus 3 minus 5 and 1. So the A inverse is equal to 1 by the determinant of A and the adjoint of A. So that means we have 1 by minus 8, as the determinant of A was minus 8, and then the adjoint, that is 7 minus 3 minus 5, 1. So that is our answer. Now the next problem. Problem number 2. Show that the matrix A is equal to 4 minus 6, 1, 1, 3, 6, and the third row 5, 7, 9 is invertible. That means same type of problem, and also find A inverse. So the solution, that means we have to find out the determinant of A at first. So the determinant of A is equal to 4 minus 6, 1, 1, 3, 6, 5, 7, 9. For the matrix has to be invertible, the determinant has to be not equal to 0. So that one is 4 into 3 into 9 minus 7 into 6. Then minus 6, that means that should be plus 6. 1 cross 9 minus 5 cross 6. Then plus 1. 1 cross 7 minus 5 cross 3. Or that one is equal to minus 194, that means not equal to 0. So we can say A is invertible. Now we are finding the cofactor matrix of A. The cofactor matrix of A. Now according to A, we can say the cofactor matrix of A, then 3, 6, 7, 9, then minus 1, 6, 5, 9, then 1, 3, 5, 7. Here that should be minus 6, 1, 7, 9. That is 4, 1, 5, 9, then minus 4, minus 6, 5, 7, and here minus 6, 1, 3, 6, then minus 4, 1, 1, 6, and that should be 4, minus 6, 1, and 3. So that is our cofactor matrix. Now from here we can say the cofactor matrix is minus 15, then 21, then minus 8, that is 61, that is 31, that is minus 58, that is minus 39, that is minus 23, and finally that is 18. So for the adjoint of the matrix A, the transpose of the cofactor matrix, that means the adjoint of the matrix A is, or the adjoint A is minus 15, 61, minus 39, 21, 31, minus 23, minus 8, minus 58, 18. Then as usual, the A inverse is equal to 1 by determinant of A and then the adjoint of A, or it is, as determinant of A was minus 194, so that should be minus 194, and the adjoint, that is minus 15, 61, minus 39, 21, 31, minus 23, and minus 8, minus 58, and 18, and that is our answer. So the next problem, question number 3, we have PQ is equal to given as 12, 10, 18, and 28, whereas P has been given, that is 1, 3, 5, 7. So find the matrix Q. So the solution is, in place of P, we can write the Q. That means 1, 3, 5, 7 into Q is equal to 12, 10, 18, 28. And that one is our P. So that one is our Q, and that one has been given here, that one. So now we are multiplying the left hand side and right hand side with the inverse of the matrix P. That means we can write it like 1, 3, 5, 7 inverse into 1, 3, 5, 7 into Q is equal to, on the right hand side, the inverse of 1, 3, 5, 7 matrix, that is inverse of P, into the 12, 10, 18, 28. Now that is our P inverse and that is our P. So the multiplication must give us the I, that means the identity matrix. So I into Q is equal to, that is normally our Q, and that one is equal to 1, 3, 5, 7 inverse into 12, 10, 18, and 28. Now look at the 1, 3, 5, 7 inverse. Now that one can be, already we have found that that one is the inverse of the matrix 1, 3, 5, 7. So we can write it here also. So that one is minus 1 by 8, and that is 7 minus 3 minus 5, 1 into 12, 10, 18, 28. That means that is from our problem 1. So just the Q means the multiplication of both the matrices with minus 1 by 8. So minus 1 by 8, and then 7 into 12 minus 3 into 18, then 7 into 10 minus 3 into 28, then minus 5 into 12 plus 1 into 18, and minus 5 into 10 plus 1 into 28. So finally we are getting that one as minus 1 by 8 and 30 minus 14 minus 44 minus 22, which can be written as 1 by 8 of minus 30, 14, 44 and 22. So that is our answer. That means Q is equal to 1 by 8 of minus 30, 14, 44 and 22. Now proceeding to the fourth problem. Let what the problem is first check. So question number 4. If the matrix A is 1, 7, 1, 8 and B is given 6, 3, 3, 2. Verify that A cross B whole inverse is equal to B inverse into A inverse. So at first we are multiplying A with B. So that one is equal to 1718 cross 6332. Then it is becoming 1 cross 6 plus 7 cross 3, 1 cross 3 plus 7 cross 2, 1 cross 6 plus 8 cross 3, and 1 cross 3 plus 8 cross 2, or it is becoming 27, 17, 30, 19. So what should be the determinant of AB if it has to be invertible? So that one is 27, 17, 30 and 19. So that is 27 into 19 minus 17 into 30, or that one is equal to the value as 3. So that is not equal to 0. So that means the inverse of A and B exists, that is invertible. So we have to find out the adjoint of AB, and that one is the 19 minus 30, that is the coefficient matrices we are finding, sorry, cofactor matrix, and 19 minus 30, then minus 17 and 27, its transpose. So that one is 19 minus 17, minus 30 and 27. So that is our adjoint of AB. So AB inverse is equal to 1 by determinant of AB into the adjoint of AB. So that one is 1 by 3 and 19 minus 17 minus 30 and 27. Let's check what happens with B inverse into A inverse. So at first we are finding the determinant of A. Determinant of A. A means 1718. So that is 1718. That means 1 cross 8 minus 1 cross 7 or 1, that is not equal to 0. So adjoint of A, we can write it as direct as 8 minus 1 minus 7, 1 its transpose. So that one is 8 minus 7 minus 1 and 1. So A inverse means 1 by determinant of A and then adjoint of A, or that one is, as the determinant is 1, so we can directly write it as 8 minus 7 minus 1 and 1. So that is our A inverse. Next we have to find out the B inverse also. So B is equal to now 6332. So determinant of B is equal to 6332, and that one is equal to 12 minus 9 or 3, that is not equal to 0. So finding the adjoint of that is adjoint of B, then that is 2 minus 3 minus 3 and 6 transpose. So the result is the same, 2 minus 3, that is minus 3 and 6, that is minus 3 and that is minus 3 and 6, the same. So we have the B inverse, that is 1 by determinant of B and then adjoint of B, or that is 1 by 3 of 2 minus 3 minus 3, 6. Now we have to verify the B inverse into A inverse is equal to A into B inverse. So that means B inverse must be at first. So we are writing B inverse into A inverse, that is 1 by 3 of 2 minus 3 minus 3, 6 into the A inverse, that is 8 minus 7 minus 1 and 1. So what should be the multiplication of the two matrices? 1 by 3 has been kept aside, so that is 2 cross 8 minus 3 into minus 1, 2 into minus 7 minus 3 cross 1, and for the second row that is minus 3 into 8 plus 6 into minus 1, and that is minus 3 into minus 7 plus 6 cross 1. So that means the result is 1 by 3, 19 minus 17 minus 13 and 27, and that one is already we have A cross B inverse. So that is verified. Now proceeding to the next problem. What the next problem says, question number 5. Show that the matrix, that is A, given 1 2 2 2 1 2 2 2 1 satisfies the equation, that is A square minus 4A minus 5I3 is equal to 0, and also hence find A inverse. So what should be the solution? At first we have to find out the A square. So A square means that is 1 2 2 2 1 2 2 2 1 cross 1 2 2 2 1 2 2 2 1. As both are 3 cross 3 order of matrix, then the multiplication is possible. So the result is here 1 plus 4 plus 4, 2 plus 2 plus 4, 2 plus 4 plus 2, 2 plus 2 plus 4, 4 plus 1 plus 4, 4 plus 2 plus 2, and 2 plus 4 plus 2, that is 4 plus 2 plus 2, and 4 plus 4 plus 1. So that means the result is a square means 988, 898, and 889. Next, we should find out the 4a. So a means 1, 2, 2. Okay. So the 4a means 4 into 1, 2, 2, 2, 1, 2, and 2, 2, 1. Or that one is 4, 8, 8, 8, 4, 8, 8, 8, 4. Next, we should find out the 5i3. I3 means order of 3. So that means the identity matrix of order 3. So the 5i3, that means 5 into 1, 0, 0, 0, 1, 0, and 0, 0, 1. Or 5, 0, 0, 0, 5, 0, 0, 0, 5. So finally, a square minus 4a minus 5i3 is equal to, already we have a square means 988, 898, that is 9, 8, 8, 8, 9, 8, 8, 9, 8, and here 8, 8, 9, 8, 8, 9, minus that one 4a, that means 4, 8, 8, 8, 4, 8, 8, 8, 4, and finally minus 5, 0, 0, 0, 5, 0, 0, 0, 5. So we have the result as 9 minus 4 minus 5, 8 minus 8 minus 0, 8 minus 8 minus 0, then 8 minus 8 minus 0, 9 minus 4 minus 5, 8 minus 8 minus 0, and here 8 minus 8 minus 0, 8 minus 8 minus 0, and 9 minus 4 minus 5, or that is a null matrix because we are getting all the elements as 0. So we have the equation that is satisfying. Then we have that one, that a square minus 4a is equal to 5i3. So we have a inverse into a square minus 4 into a inverse into a is equal to 5 into a inverse into I3. That means multiplying both sides by a inverse. So we have a inverse into a square, that means a inverse into a into a, so that one is becoming I. So I into a minus a inverse into a, that one is becoming I. So minus 4 is equal to 5 of a inverse. Now from here, so we can write out that A inverse is equal to 1 by 5 and A minus 4 of I3, because that one is I3. So we have the value that is 1 by 5. A is equal to 1, 2, 2, 2, 1, 2, 2, 2, 1. That is our A, minus 4I3, that means 4, 0, 0, 0, 4, 0, 0, 0, 4. So finding the value just here, that is 1 by 5 and minus 3, 2, 2, 2, minus 3, 2, and here 2, 2, minus 3. So that is our A inverse. Now proceeding to the next problem. Let's check what the next problem say. Question number 6. Find the matrix A satisfying the matrix equation. That means an equation has been given here, and that one is 2, 1, 3, 2 into A into minus 3 to 5 minus 3 is equal to an identity matrix 0, 1. So to solve the problem, let us suppose we have B cross A cross C is equal to I2. So here we are multiplying both sides at first, multiplying both sides by B inverse and C inverse. That means, suppose for that B inverse into B into A into C into C inverse. That B inverse and C inverse has been multiplied here. That one is equal to B inverse into C inverse into I2. So that one is becoming I2. That one is becoming I2. So the left hand side is now only we have A, and right hand side is now B inverse into C inverse. So from here, if we find the inverse of B and C, we can find out the value of A. Let's find. So at first we are finding the determinant of B. That means if that is not equal to 0, the B can be invertible. 2, 1, 3, 2. So that means 2, 1, 3, 2, or 2 cross 2 minus 3 cross 1, or 1 not equal to 0. So adjoint of B is directly we can write, that is 2, then minus 1, then minus 3, then 2. That means that one is equal to 2 minus 3 using cofactor. 2 minus 3 minus 1, 2, its transpose. Okay, we need that one. So B inverse means 1 by determinant of B and of adjoint of B. So that one, as the determinant is 1, so the B inverse is 2 minus 1 minus 3, 2. Then we have to find out the determinant of C. If the determinant of C exists, that means not equal to 0, minus 3 to 5 minus 3. That is minus 3 to 5 minus 3, or minus 3 into minus 3 minus 5 into 2 or minus 1. So we are finding the adjoint of C, and that one is minus 3 minus 5, then minus 2 minus 3. Its transpose, so that one is minus 3 minus 2, that is minus 5 and minus 3. So C inverse, that means 1 by determinant of C and adjoint of C, as that is minus 1 is the determinant. So we have 3, 2, 5 and 3. So for A, we have to find out the value of B inverse into C inverse. So that one is B inverse means 2 minus 1 minus 3, 2. 2 minus 1 minus 3, 2 into 3, 2, 5, 3. Or we have the result as 2 cross 3 minus 1 cross 5, 2 cross 2 minus 1 cross 3, minus 3 cross 3 plus 2 cross 5, minus 3 cross 2 plus 2 cross 3, or that one is 1, 1, 1, 0. So that one is the answer or solution of the matrix A. Let's proceed to the next problem, or the problem number 7. The question is, if the matrix A is equal to 2, 1, 3, 4, obtain the matrix B such that AB is equal to BA is equal to the identity matrix. Let's check. Since we have AB is equal to BA is equal to I, then B is equal to A inverse. So we are finding the determinant of A, 2, 1, 3, 4, that is 2 cross 4 minus 3 cross 1, or is equal to 5. Then what should be the adjoint of A? That is 4 minus 3 minus 1, 2, its transpose, that means 4 minus 1 minus 3, 2. So what is the B? So B is equal to A inverse is equal to 1 by determinant of A and then the adjoint of A, or the result is 1 by 5 of 4 minus 1 minus 3, 2, and that is the solution of the matrix B. Let's proceed to the next problem, question number 8. Here we have matrix A is equal to 2, 1, 0, 3, and B is equal to minus 1, 1, 2, minus 1, and also C has been given, that is 0, 1, minus 1, 1. Question is, if Cx minus AB is equal to 0, that means 0 is a, or O is a null matrix, then find matrix X. So let's check what is the solution. We have Cx minus AB is equal to the null matrix, so we can say Cx is equal to AB. Now what is the value of Cx? Now we can put the value of A and B here. So C into X is equal to 2, 1, 0, 3, and minus 1, 1, 2, minus 1, or finding the matrix multiplication result 2 cross minus 1 plus 1 cross 2, 2 cross 1 minus 1 cross 1, 0 cross minus 1 into plus 3 cross 2, and 0 cross 1 minus 3 cross 1, or the result is 0, 1, 5, minus 3. So that one is our Cx. Now from Cx, we can find out that multiplying both sides by C inverse. So that means we are multiplying both sides by C inverse. So that one C inverse into C into X is equal to C inverse into 0, 1, 5, minus 3. That means we have to find out the inverse of C. So that one is equal to I2. So the result is becoming X is equal to C inverse of 0, 1, 5, minus 3. Let's find out the C inverse. So determinant of C is equal to 0, 1, minus 1, 1. Let's check we are right or not. 0, 1, minus 1, or 1. So that one is equal to, we have 1, that is not equal to 0. So adjoint of C is equal to 1 minus 1, 1, 0. So C inverse means C inverse means 1 by determinant of C and adjoint of C, or we have determinant of C means 1. So the C inverse is 1 minus 1, 1, 0. So what should be the value of X? So X is equal to, now C inverse, that means 1 minus 1, 1, 0. That one cross 0, 1, 5, minus 3. So the value of X is now, that is 1 cross 0 minus 1 cross 5, 1 cross 1 minus 1 cross 3, 1 cross 0 plus 0 cross 5, and 1 cross 1 plus 0 cross 3, or the result is minus 5, minus 2, 0, and 1. Let's proceed to the next problem. Question number 9. If we have A is equal to 1, 1, 1, 2, 1, 2, 3, 2, 4, and B is given as 0, 2, minus 1, 2, minus 1, 0, minus 1, minus 1, 1. Then verify that question. Then verify that 1 is the inverse of the other. So we can find out the inverse of A or B, and that should be the inverse of the other. But another way, that if A and B are inverse with each other, that means we have A cross B must be equal to an identity matrix. So let's check. That is A cross B, 1, 1, 1, 2, 1, 2, 3, 2, 4, cross 0, 2, minus 1, 2, minus 1, 0, minus 1, minus 1, 1. Let's check what should be the result. 0 plus 2 minus 1, 2 minus 1 minus 1 minus 1 plus 0 plus 1, that is the first row. 0 plus 2 minus 2, 4 minus 1 minus 2, minus 2 plus 0 plus 2, and now 0 plus 4 minus 4, that is the third row is going on. 6 minus 2 minus 4, and minus 3 plus 0 plus 4. So the result is obviously an identity matrix 0 0 1, or that one is equal to I3. Hence we can say B is the inverse of A, and also the vice versa.